Hey everyone, and welcome to today's Explainer. We're going to dive into a topic that is quite literally everywhere right now, artificial intelligence. I know, there's so much buzz, a ton of jargon, and honestly, just a lot of confusion about what AI actually is. So today, we're cutting through all that noise. We're going to break down exactly how it works, what it can do, and most importantly, how it actually learns, all without the confusing tech speak. By the end of this Explainer, you're going to have a rock-solid understanding of the technology that's totally reshaping our future.
Okay, let's just jump right in with a pretty wild real-world example. Imagine you're sitting in this massive university lecture hall in China. You think you're safely hidden in the back row, right? You pull out your phone, you start playing a game, and boom, suddenly you're caught. How did they know? Well, it's not a teacher up there with binoculars. It's actually a network of cameras actively scanning the room, analyzing student posture and behavior in real time, and automatically detecting if you're slacking off. No way, right? But this isn't some sci-fi movie. This is happening right now, and it is powered completely by artificial intelligence.
Section 1. AI in the real world. To understand how that kind of technological magic actually happens, we first need to look at how AI operates in our everyday lives.
Let's start with a really simple foundational definition. Put simply, AI is just about giving computers an artificial brain. And what surprises a lot of people is that this isn't some brand new Silicon Valley trend. The concept actually dates way back to the 1950s. The goal has always been to take a machine that just follows rigid, line-by-line instructions, and instead give it the ability to process information and make decisions in a way that kind of mimics human thought.
And hey, you don't need to be at a high-tech university to experience this. You are already interacting with these artificial brains every single day. You know when you type a super vague question in a Google search and it somehow knows exactly what you meant? That's AI. When you ask Siri to set a timer, or when Amazon magically recommends that exact pair of shoes you were literally just thinking about buying, that's all driven by artificial intelligence working behind the scenes, anticipating your needs using massive amounts of computational power.
Moving on to Section 2. How do computers learn? Now, the really fascinating part is how we actually bridge the gap between a cold piece of machinery and an active, learning brain.
Think about how a human child learns. A kid learns just by existing in the world, right? They talk to their parents, visit new places, touch a hot stove, they experience life. And that organic experience builds their intelligence over years. Now, contrast that with a computer. A computer obviously can't just take a stroll around the park. So to get a similar result, we teach computers by constantly feeding them experiences in the only language they actually understand, data. We feed them massive, almost unimaginably huge amounts of data, millions of images, billions of text documents, endless spreadsheets. The more data they consume, the more patterns they recognize, and the smarter they become. It's like a giant puzzle they're constantly piecing together.
Section 3. AI versus normal technology. But how exactly does this whole learning process make AI fundamentally different from the normal everyday software you've been using your entire life? Well, think about normal tech, like Microsoft Word. You could type 1,000 brilliant essays into Word, but tomorrow when you open up a totally blank document, Word hasn't learned how to write the essay for you, has it? It stays exactly the same. It doesn't magically gain new powers. But AI operates completely differently. Take smart traffic cameras, for example. These cameras watch cars pass by all day, every day. And with every single piece of traffic data they process, they actually get smarter. They learn to better predict traffic jams, spot license plates in awful weather, and even optimize traffic light timings. They are actively evolving. So here is the absolutely crucial point. With all this constant learning going on, we run into a really fascinating question. We all use apps like Instagram, WhatsApp, Facebook, YouTube. We're pumping mountains of our personal data, our behaviors, our preferences into these systems every single second of the day. With all that data feeding the machines, shouldn't AI be fundamentally smarter than humans by now? Are we already outmatched?
Well, to answer that, let's look at Section 4, the two types of AI. Understanding this difference is absolutely vital to grasping the current limits of the technology. We really have to divide the technology into two distinct buckets to make sense of where we're at right now. On one side, we have general AI. This is a system capable of performing a massive variety of different tasks, learning across completely different domains seamlessly. On the flip side, we have narrow AI. This is a system that is incredibly powerful, but completely locked into doing just one specific, particular task. Let's break down general intelligence first. This is exactly what we as humans have. Just think about your daily life. You can cook a meal, eat it, sing along to the radio, dance around the kitchen, sit down at your laptop to write some code, and then go study for an exam. We shift between completely unrelated tasks without even breaking a sweat. We can apply logic from one part of our life to solve a problem in a totally different area. That amazing fluidity, that is true general intelligence.
But here's the major reality check of today's explainer. Actually, as of today, right this second, general AI simply does not exist anywhere in our industries. We don't have a computer that can paint a masterpiece, then immediately decide to go balance a checkbook, and then somehow learn to ride a bike. That all-knowing, multitasking AI from the sci-fi movies? Yeah, that is still purely fiction. Instead, literally everything we interact with today is narrow AI. It's highly specialized. For example, let's look at a self-driving Tesla. A Tesla that's been trained extensively on US road data performs incredibly well there. It knows the lane markings, the specific traffic signs, the typical flow of American traffic. But if you take that exact same super advanced car and drop it onto roads in India, it struggles massively. Why? Because the environment is totally different. The traffic patterns are distinct, the unspoken rules of the road have changed, and the car completely lacks that specific local training data. It only knows exactly what it was fed. It just cannot generalize.
Another really great example of narrow AI is in medicine. Today, we have hospital software designed specifically to predict the chances of cancer by analyzing patient scans. And let me tell you, it is amazing at that one single job. Sometimes it even spots tiny anomalies way better than a human eye could. But that is all it can do. It can't check your reflexes, it can't prescribe you cough syrup for a cold, and it definitely can't sit down and comfort a worried patient who just got some bad news. A human doctor, while maybe taking a tiny bit longer to read a single scan, has the general intelligence to do that scan, plus 100 other vital medical tasks.
Which brings us to our final part, Section 5, Humans versus Artificial Intelligence. Let's pull all of this together and see where we truly stand against the machines today, separating the hype from the actual reality.
When we weigh humans against AI right now, there is this totally fascinating trade-off. We have relatively low raw computational power. I mean, we can't process a million math equations in a millisecond. But our versatility is massive. We can do almost anything we set our minds to. AI, on the other hand, possesses this immense, mind-blowing computational power, but it remains heavily trapped in its single-task limitations. It is the ultimate specialist, but a terrible generalist.
So I want to leave you with this thought to ponder as we wrap up today's explainer. We know narrow AI is already unbelievably powerful at single, isolated tasks. So what happens to our unique human advantage of versatility when developers finally figure out how to start seamlessly linking those individual superpowered tasks together? Will we maintain our edge, or will the very definition of intelligence shift entirely? It is a fascinating future to keep an eye on, for sure. Thanks so much for joining me today, and keep learning.